Hello team, in this video we're going to talk about orchestration. I'm going to start talking about what is orchestration. So one way of looking at orchestration is that orchestration is a set of automation solutions to manage a service. And there are many tasks related to offering a service. So let's consider the lifetime of a service. So the first thing we need to do is of course deploy this service. So this is one task that we can automate. After our service is deployed, we might need to configure it so that it runs the way that we want. And of course, we might need to reconfigure the service at different points in its lifetime if its configuration changes. Another task that we may need to do is to update our service. Let's say if you release a new version 2.0, then we need to update the running version from 1.0 to 2.0. And here I'm showing that the update may take some time to complete, and we're going to see why this is. So updating is one task that we can automate, and it's integrated in the lifetime of the service. And after we have updated the service, we might also need to reconfigure it. So reconfiguration comes up again. And if our service runs for a long time and attracts a lot of users, so it will run on many servers, then we are bound to have failures. This might be software failures, bugs, and might be hardware failures. So when failures happen, one thing we can automate is the restoration of the service. So we're going to take down the parts of the service that have failed. For example, if a server is down, we're going to stop running the service on that server and going to move it to a server that's okay. And this is what we call restoration. So we have failures, we want to detect that the failure happened and automate the restoration. And finally, we want to have auto-scaling throughout the lifetime of our service. And here auto-scaling is allocating more resources to our service or less resources to our service depending on how much demand we get. So if it's Black Friday, there's a lot of users trying to use a service, then we auto-scale up. And then once Black Friday is over, we decrease the amount of resources allocated to our service so that we don't pay what we don't need to. So orchestration is this integration of different automation solutions so that we can manage a service throughout its lifetime. We are going to talk more about each of these aspects of orchestration in later videos, but one key idea that's used in all of them is that we should specify the building blocks of a service. So we partition a service into small little blocks, and then the orchestration solution assembles these building blocks to achieve our goals. As examples, we can think of map and reduce as building blocks. And then Hadoop and Yarn are the orchestrators. So Hadoop and Yarn will take care of taking in our map and reduce specifications and running them on the cluster. If there's a failure, they're going to restart the map or the reduce instance that was impacted. One problem with map and reduce is that they're not general, so we can't develop any type of application using map reduce. And this is one of the reasons why containers are more common today. So containers support any type of application, and it's one easy way of specifying building blocks. And Kubernetes is one orchestrator that manages containers. We can also have virtual machines as building blocks. One problem with virtual machines is that they are bigger than containers, so they take up more resources. But if we use virtual machines as building blocks, then we can use an orchestrator like OpenStack to manage our virtual machines. And these building blocks have common properties across all different granularities. So these building blocks are usually ephemeral, so they're not permanent. We can create them rapidly and we can tear them down when we don't need them anymore. We can replicate these building blocks, we can replace them, and we can combine them in different ways. And each of these properties are used to achieve goals in orchestration. For example, blocks being ephemeral allow us to easily deploy and update each building block. Our ability to replicate blocks allows us to auto-scale our service. For example, if the load increases, we can create new blocks and absorb the increased demand. Blocks can be replaced, so if a server fails, we can just let that failed block go away and create a new one. So we replace the failed block with a new one, and this supports restoration. And the ability to combine different blocks allows us to build complex services. For example, we might have a building block that takes care of handling web requests and another building block that takes care of a database. So we can combine these two to create a web application that has permanent storage.